as far as acids and bases, would be doing a neutralization reaction.
Can you do an example of that?
Yes. And a neutralization reaction, it can be a net ionic equation. So how about H2SO4 plus simple NaOH? We did cover this. So how do we do this? You guys remember how to do this?
You're gonna put H2 with OH, and then Na with.
Yeah, so do I get H2OH? Is that okay? Does that look all right? No, we can't do that. So what you have to do is there's a set of steps like we did before, like in the videos that we have from before, is you want to write reactants, especially these both are aqueous, right? This is an acid, it's aqueous. This is a base, probably aqueous, right? Reactants that are aqueous as ions. So I can't just say, okay, I'm gonna take the hydrogen, the cation part with the anion and just poop H2OH, and I'm not gonna have NaSO4 either, or SO4Na. No. So I gotta let's write the ions. What are the ions here from H2SO4? We just did something like that, right? In the name. So notice this kind of goes together. The naming skill involves you breaking apart ions, whether it's an acid or an ionic compound. So that practice actually helps with this. What are the ions here?
You have 2 hydrogens.
Good.
Positive.
2 hydrogen.
1.
And 1 sulfate. What are the charges?
So positive for 1 for hydrogen.
Good. And then so the sulfate has to be 2 minus if I have 2 plus 1s, right? They have to equal 0. But this one's probably easier. We know what's the charge of sodium. You probably know that by looking at the periodic table. So
+1.
+1 because it's a group 1A cation. So if you forgot hydroxide, you could actually figure out what does hydroxide have to be logically. What's the only charge it could have?
-1.
Yeah. Okay. So then you want to switch partners. Switch. And net 0 charge. Okay. So sodium's going to go with sulfate, and hydrogen ion will have to go with hydroxide. So what are the products going to be? When hydrogen and hydroxide go together, what will they actually make?
H2O.
Good.
Water.
Yeah, so H2O, perfect. And how about this one?
Sodium sulfate.
Salt.
Sodium sulfate.
Yeah, what's the formula for sodium sulfate? Is it just NaSO4? Or actually, and actually, which one goes on the left?
Na2SO4.
Na2. I'm going to need 2 plus 1s to cancel that 2 minus. And I always want to go cation first, then anion. So it's sodium and then sulfate. Okay, so those are the products. 3, balance. All right, so I'm going to write in the whole thing. H2SO4 plus NaOH goes to H2O plus Na2SO4. And then I want to balance the coefficients, and I'm going to do metals first. I have 2 sodiums there and 1 there, so
1 in front of the NaOH. I mean, a 2.
2, yeah, okay. And then I get that. So let's see, and I still have 1 sulfate on each side. So I'm going to go to the hydrogens. How many hydrogens are on this side?
2 or 4.
4. Good. 2 times 1 plus 2 is 4. And over here I only have 2, so I'm going to
In front of H2O.
put a 2H2O. 4. Find the states. So actually, we know H2SO4 was aqueous, and NaOH NaOH was also aqueous, given to us. What about water? What's the state of water going to be? Sorry?
A liquid.
Good. Water is always a liquid. And we'd have to look at a solubility table. Sulfate's usually soluble unless it's with silver, calcium, lead. So sodium actually is always soluble. So this one has to be aqueous. So we'd have to get that from a table. Aqueous table. All right. So that's actually a balanced equation after I do that. Right. But we can go further. We could do the total ionic equation. Moving this up. Hold on. Let's move this over. Okay, so the total ionic equation means write all aqueous as ions from this equation, and then leave the others as is. Quote, as is. All right, so the only thing that's not aqueous is the two waters. So I'm going to leave them as is. They're going to be in the equation, 2H2O liquid. But now I have to break this. Okay, should we start over here? We already broke H2SO4 apart, right? From before, we knew it was 2 hydrogen ions, aqueous. So now I need to show the charges when they've separated, right? When they're together, should not show any charges, right? Plus SO4 aqueous, 2 minus, right? What about that one? So actually, we'd already broken apart sodium and hydroxide, but now we have a 2 in front. So I'm going to multiply that by 2. I'm going to have 2 sodiums plus and 2 hydroxide minus. And those are also aqueous. Okay. And then we also, from up here, we have Na2SO4. So this is kind of the new one. Well, that's going to make 2 sodium ions aqueous plus sulfate, 2 minus aqueous. And so that's my total ionic. Next step, usually to me, the total ionic is kind of a throughway to get to the net ionic, but let's cancel spectator ions, which are AQ on both sides. What's aqueous on both sides?
We might just keep the H2O.
I'm going to keep the H2O, but what can I cross out? So can I cross out everything over here?
The Na and the
Yeah, I have sodium aqueous on both sides. What else is aqueous on both sides?
SO4.
The SO4. So that's all I'm going to cancel. I'm not going to cancel everything aqueous because this thing is not represented as aqueous over here, right? Okay. Oh, I'm sorry. I messed this up. There should be a 2 right there, right? I forgot that. I got excited. Okay. So then this one actually invokes my 7th rule. Divide out common denominator. I'll put it if necessary. It doesn't always happen. So 2 S's. So 2 C's. I can't remember. Okay. Well.
Excuse me, I have a question.
Yes.
When you end up with aqueous in both sides, like there's like, let's say there's no liquid in this in this example that you're working right now. What
Yes.
happened after that?
So if everything's aqueous, then everything will cancel. I can do an example of that if you'd like.
Yeah, please.
So that will never happen with an acid base. With an acid base, as we've defined it, you're always going to make water. But I'll do one of those. Should we just finish this one real quick?
Yes, please.
Okay, so we have 2H plus aqueous plus 2OH minus aqueous goes to 2 water liquid. So I'm going to divide out the 2. And 8. What's left equals net ionic. So that's what's left. When a hydrogen ion in solution bumps into a hydroxide ion in solution, they form water. Liquid. That's my net ionic. And so this one's kind of an interesting reaction because you won't see the formation of water in water. But actually, this actually produces a lot of energy. So if you react an acid and a base, the test tube would heat up in your hand. Sometimes it can be really hot. Where if we're mixing concentrated acids, we have to use ice. It can heat up so much it can crack a container that it's in.